Um, can you wait? Hello everyone. You can you wait for a minute? Our teammate is still
Yes. Take your time.
Is
yeah.
okay,
Thank you.
Thank
Smart here.
you.
Oh, sorry.
Okay,
It's
start.
okay, Paul. You can start now.
So, hello everyone. Hello, audience. So, it's my honor that today we have to present about our project that we have been doing so far. And here's the result, which is Kai. We name our project is Kai, and basically the Kai is Khmer script spell checking. So next. And first of all, I would like to express my gratitude and my thankfulness to Mr. Rina Boy, who is my our supervisors that have giving feedbacks and guide us during our implementation stage. So the three guys on in the bottom are our members. The first one who is Sawan Marita Hing, and Sovichia Sinat, and as well as Sambatsai is me. Next. So here are the table of contents that we are going to cover today. First is introduction, followed by the problem statements, and followed by the solution. Also, we state our objectives of applications, and also as we explain about technologies, followed by implementations and our future works. And finally, we go into the demo of our application. Next. Next. So in the introduction, I would like to stress out about the Khmer language. So Khmer language is an Austroasiatic language spoken by the Cambodians and the official language of the Cambodia. So through the Hinduism and the Buddhism, the Khmer language has been heavily affected by the Sanskrit and Pali, particularly in the royal and the religious registers. So on the image on the right side, you can see the flags of the Cambodia and no backward, and the image on the bottom one is just the Khmer, just the example of the Khmer consonants. So next. So we come to the problem statements. Next, next slide, please. Next slide. So on the problem statements is the reasons and the problem that we have seen, and that we have the motivation that we want to solve this kind of problem. So the first problem that we have seen is that people use the wrong spelling. So why people use the wrong spelling? We have three main reasons. Because Khmer language is the complicated with many Bodo characters. Like for example, like Khmer characters, we have like the legs and the like Tresap or Batapi, or all of those things are very complicated to understand and to memorize it. And the second reason is about the homophones, which is the word that pronounce the same but spelled different ways. So it also the reasons that people would not recognize the word as well. So lead to the use the wrong spelling. And the third reason is that the Khmer words requires memorizations. Like for example, the word spelled differently, spell different lead that it is supposed to spell. To pronunciation, for example, like um, it it's supposed not to pronounce that way, but it's spelled that way. It's so weird. Yeah. So the second one is the beginner of the Khmer language learner. So like for the foreigners, they study about Khmer language, and they use the Khmer language different way. They use the wrong spelling because they are just the beginner of the Khmer language learner. So the problem is that when people use the wrong spelling, our value of the Khmer language will be lost. So our team, we have seen this kind of problem. So it motivates us to build up an application that solve this kind of problem. So next. So here is the objectives and the goals. So our goal is to have anyone that unfamiliar with the Khmer language to understand and write it correctly. Next. So the solution, what we can do is to create a program that is a website-based application that allows users to submit their Khmer words or the Khmer phrase paragraphs, and then they receive back the word correction suggestions. Which, like for example, when you spell something wrong, you will be able to click on the wrong word. In the wrong word, it will be highlighted in red, and you'll be able to click on it, and you will see the list of suggestions. So you can click on the right one. Yeah, that's the solution. Next. So on the technology stage, will be presented by the Mr. Vijaya.
Okay, thank you, Mr. Sambat. Let's go to the technology. Okay. Okay, so for our technology side, we use Python for our main server with the help of Fast API web framework. And for the front end side, we use Next.js or React Native or React to build a beautiful and easy to use user interface for the user. And for our spell correction, we use the help from Handspell. Wait. Oh, I thought I didn't open the mic. Sorry. And for the spell correction, we use the tools such as SimSpell and also Handspell, which is the most popular, one of the most popular correction library out there that used by LibreOffice, Firefox, and also Mac OS also. So let's talk about the implementation. So this is an overview of our application. From our web page, we send the input string to the server, and the server will look up for the suggested word in our database. And our database here are just a simple JSON document file. And when it's found, it will return back a suggested word, and the server will return back, and the front end side will display the incorrected word in red, and will pop up a suggestion for it. So first of all, we got our data as in Khmer word from our professor. He helped us a lot. This at first, our implementation, we just use a plain text file from all the word, and if I correct, it's about 75,000 word in total. Yes, and then we split them into dictionary file to make sure that SimSpell and Handspell are able to perform their work. So first off, we clean the data. We for Handspell, we created a .aff, which just it's almost like a programming language of itself. We tell we wrote instruction of what is similar, where is the which key are near each other, which word are allowed, which to ignore, and what type of character encoding that we should use. And for the .dic file is in the middle. It's just our plain word in Khmer that we wrote into a different type of file. And lastly, we have another file that for SimSpell, which take the word and take the number of frequency at this stage. Then we take another file that from our instructor that for phonein, and with this we can perform a search on the word that might sound similar. So this is what the server will return back in our API. It's just a JSON and with suggested word, and it tells incorrect or not correct. For example, like in this picture, the Piet So Lang is forgot the top sign. And for Cambodia, it Cambodia, which is also incorrect. That's why it suggested Cambodia. Okay. So this is what the front end will look like. We type on the one of the box, we click check, and we will get back the suggestion as in the head third character. And when we hover over it, it will try to list out all the words that it tries to suggest for us. It's work for both website, a large screen and also a mobile view. For the future work, I will leave Mr. Munir to present.
So for our future work, our team. So for future work, our team Kai want to expand the development into two sites. We see as an application for user use and an application for the developer use. For the application for user use, we want to expand it into a language suggestion keyboard, similarly to what you currently have with the default keyboard that you bought in smartphone, with the suggesting word inside the keyboard within it when you type the word. And we also want to extend this project into an auto correction, meaning that we suggest the word that you want to type, and we also auto correct the word if you type it wrongly. And let's take a look for the developer side as well. For developer side, we want to create a Khmer searching engine. This can enable us as developer to create more application that built-in support Khmer language. So we can keep using our language instead of using a foreigner language. The second one is we also want to use this platform to work on Khmer segment analysis, to create a library for analysis Khmer word. For example, like text blob, they have their own analysis where they break down the word. They give each points to the word with the analysis point. And for the third one is we want to work on Khmer NLP. For this part, it is enable us to do a lot of big projects such as chatbot or any automation that related to our Khmer language. For example, we also can implement a home assistant using this NLP as well. So let's move on to the demo. In here, you can just scan the QR code and it will link you to our application.
I present this part or you, Munir?
I can share my screen.
Okay.
Yeah, you can put it as a QR code so people can scan in.
Okay.
You can scan the QR code, or you can click on the link that I provide in the chat.
Yes, so for example, if I'm going to input, so this is the first thing that you see in our application when you enter in our Kai website. As you can see here, this is where you can input your text, and on the right hand side is where it will display the correction. So for example, if I said that today is Saturday, So let's check if there is any error exists.
Maybe try to refresh the site again.
Okay, sure.
Let's try again.
So we try again.
Let's do some short word first. Like just say some kind.
Sorry.
You just type. I think you should type it by yourself. Don't paste. I think maybe your copy text would be contain English word or something, maybe like contain English in the Unicode, like English text.
Sometimes Google separated for us. So yeah.
Yeah. I think you should type it.
Oh, Richie, can you present it? I don't know how to type in Command.
Oh.
Someone to do it. I don't know how to type in Command too.
Also, another problem here we're facing is that we are currently using our computer as the server. Because when we try to host our application on other server, they required us to pay the budget to get the RAM and also the server to run properly.
So here the demo that we use our application. So first of all, let's type wrong word inside the input. So like we want to say Terian, but we don't have like with Terian, but we spell it with the no character here. Then we click on the check. Yeah. So like it's the same because the server was. I'm sorry, I don't know how to say it. At the moment, it works. Sorry. It is. Oh, yeah, it works. But why? Why it's slow?
Got many requests.
Maybe because of the server is slow, or maybe have some problem with the server side because we have also host it inside the local one, not the server. Here, you can see the suggestion from the word that is incorrect. Like here, Terian, where is Rian? Here is the Terian one. So now I would say không sờ lá, but cắm cụ chỉ, and then the result would be
Should we start to answer the question? Since it's a bit slow, the server a bit slow.
So you have 3 more minutes to Q&A session. Thank you.
Okay, thank you. So how many Khmer words do you have in your dictionary? 75,000. Bon. Somebody you didn't use yet. A good presentation. What question for tech with zero with space does it work? by that you mean that the word doesn't have any space in between each word បងមិនណា
Currently, our system also work if you give out a long sentence. We have the segmentation by segmented out Khmer word, each word like for example ខ្ញុំទៅសាលា it will segment ខ្ញុំ as one word, ទៅ as one word, and សាលា as one word.
yes it works
So if you're happening to wrongly spell each one of those words, our system will correct and give suggestion. Unfortunately, we have a problem with our server.
we using our professor Rina text segmentation for that part so it should work does it in Visual Dictionary I'm not sure about that it dictionary that we got and we tested it with
So may I ask that do you want to give it a try? And we'll give you 2 more minutes to test it again. But if you, yes.
I have found the problem that because the server was trying to request from many audience, so that's why it's slow. Yeah, because we give the website for audience test, so it's respond many requests. So let's try again, maybe. Vijaya, you present it, or and please audience stop make requests at this time.
okay sure
Vijay, you can go ahead, bro.
yes let's say Solvang maybe so it does not have a let's check it so it say it incorrect and it will suggest a lot of word but of course the correct word should be this one and like Slovak Cambodia I guess so Slovak is the same and how about this one it's will suggest to only Cambodia yes that is it for our presentation thank you for joining us
Rani, we cannot hear you. Yeah. Yeah, we still cannot hear you. Maybe you can refresh Google Meet, and I think it will work. Maybe yeah, it's okay. I think there might be problem with the yeah.
I'm sorry. So can you hear me now?
Yes.
Okay,
Yes.
so for the next team, you have 10 minutes for your presentation, and I will end you at 11:47. Thank you.
So, hello everyone. I'm gonna share my presentation. So, good morning everyone. Today we are from Deep Learning course. We're gonna present our project on Khmer word segmentation. So the table of content for today is the first one is introduction, the second one is methodology, the third one is implementation, the fourth one future work, the fifth one is demo, and the last one is Q&A. So who involved in this project? First of all, we would like to thank Mr. Rina for instruct us in this project, and our teammate is Mr. Pochai and Ms. Renier, and also Mr. Bisset. So come to the introduction. Word segmentation is a program that involves breaking down a string of written language into its corresponding word. So in a simple word, we take a sentence and break it into a word. Just like in this example, we take a example in Khmer language, clean line. Also, if we do the word segmentation, it will break into a word. So clean is a word, Chingai is a word as a line, and all easily segment word and determine word boundary from a given phrase or article, and able to identify multiple possible meanings as my sentence can have multiple valid word boundaries that still produce perfectly valid meaning. So in here it's mean that Khmer word it can when it comes into a sentence, it can have multiple meaning according to its boundary. It's like the word salarian. The word salarian we can consider it as a one word salarian. It means school, or it can break into two words, just like one word is salah and another word is real. So it's something like that. So come to the problem. Since Khmer word doesn't have a standard for separating each word like how spacing work in English, we need a way to analyze a sentence or article and able to break it down into it's individual word. For example, in English, if we write "I go to school," so we can see clearly that this four word consists in this sentence. I is one word, go is another word, to is another word, and the last word is school. So each word in this sentence is separated by a space. But in Khmer language, I just like example in here, ខ្ញុំទៅសាលារៀន so there is no space, so we don't know how many words in this sentence. So if we separate it ខ្ញុំ is a word, ទៅ is a word. Just like I mentioned before, it can be សាលា is a word and រៀន is a word, or សាលារៀន is a word. So this is our problem, that we cannot, we don't know that how many words in that sentence, so we need to segment it. So come to the methodology, Mr. Pochai will present this part for you guys.
Yes, please go to the next slide. So here are the technology that we are using for our project. First one is that we use HTML, CSS, and JavaScript, Vue.js and Tailwind for our front end, and for our back end we have Python and PyTorch, which is one of our library. And for the Fast API, we use it for connecting the back end with the front end. And please go to the next slide. Here are the method that we have in our Khmer word segmentation project. They are SimSpell, international component for Unicode, which we call in short it is ICU. The third one is conditional random field, which is we can call it CRF, or the fourth one is the recurrent neural network, or we can call ONN as short. And please, I will explain this more detailed in the next slide. So as we can see here, we have the graph that which is showing the total of training data that we have trained, which has the total of 12,000 data, and those data are from Khmer article, which contain mostly Khmer name and entity. Those data set is only for testing purpose only, and doesn't really represent a real world use case, since it a bit based toward the ONN method. And so in this case, as you can see that the accuracy of ICU and SimSpell is a bit low, since both are use dictionary based approach. Just for the ICU, it existing dictionary in a dictionary based approach, and SimSpell it also use a dictionary based approach, but we provide with our own dictionary. And for the CRF, as you can see, the data that we train, the accuracy we get is 4,541, and normally CRF it's work really well, since the technique to train is a bit advanced and complex with the algorithm technique which are published by NIPTIC, and it also work quite well with this data set that we training. So we have the ONN is we have found out that with this case the ONN is work out the best with the most well one, which because ONN are being trained on similar data set, which we with this ONN is with it's our own word segmentation based on recurrent neural network. So that's why it's work most accurately in this case. So let's move on to the next slide. So for now we have the implementation part, which Mr. Bisset will continue this part.
Okay, so let's continue to the implementation part. So first of all, Mr. Pochai present us like the four segmentation methods that he gave us, which include the SIMSPEL, the ICU, the conditional random field, and the recurrent neural network. But in this case, like we want to talk about the recurrent neural network only because it's something that we work from scratch, and the other one we based on some other people work like research paper and libraries. So just to give a brief introduction of what is recurrent neural network. This is not like very it's not going to be a deep dive into the topic because it's very advanced. So it's just a brief intro so that you have an idea what is recurrent neural network is. So ONN is like a type of neural network that uses their reasoning from previous experience to inform the upcoming events. Because of their internal memory of previous events, ONN can remember important things about the input they receive, which allows them to be very precise in predicting what's coming next. This is why they work well for sequential data like time series data, speech, text, audio, weather, or stock price, and which is why it's very common in natural language processing or NLP problems, such as keyword segmentation that we just right now. So next slide. So the process that we implement using the ONN. So first we scrap data from client news article and manually segment the articles. The data are provided by our instructor. And then we fit the segmented data into our recurrent neural network. We train the data by splitting into the 80% for training and 20% for testing. And the last one is given a sentence. The neural net model will determine whether the character is the start of the sentence, in a start of a word in a sentence. Next slide. So next, I want to give you some idea about the recurrent neural net architecture that we use. If you look at from the bottom up, first we have the input. In this case, like Arisala, so we break it down each character by character, and then we do the encoding. So computers, they don't really understand well with they don't understand characters, so they only understand numbers. So we have to find way to fit input into turn it into numbers, which in this case we do the technique called one-hop encoding, and then we fit the encoded data into the recurrent neural network in order to train it, and the output will be classified as two classes, which is the 0 and 1. So the neural network will determine whether the output should be a 1 or 0, where 1 means that it is the start of the sentence, and 0 is that it's not the start of the sentence. So in this case, the Parisala part, the output will be something like 1, 0, 1, 0, 0, 0. So like go is the start of sentence, and the I is so is 0, and the so is 1. So it's like the so and so is the start of the word. So it means we can segment it into a Tari and Sala. So that's it for the neural network architecture. Next slide. So for the future work, Mr. Pochai will present.
Yes. So please go to the next slide, please. So yes, also I will be quick about this part. So I think that it would be even great if we implement like we combine our project with the spell check project to make the project more functional. So the project can be used or include into the spell check project. Also the part of speech, because of the part of speech is used to define a noun, like adjective, phrase, or any other part of speech. So it could be a good idea to add Khmer word segmentation into that section of speech to separate word before getting the different part of speech. Also, I think that it's also a great idea to implement it with the voice recognition. Because we can use the benefit of Khmer word segmentation to divide the words from voice recognition into text by allowing the user to have a better experience by seeing the space between word after being translated from voice recognition. So now let's move on to the demo part, which we have already recorded.
So I will show the record that we record about our demo in here. So let's start. This is our interface. That the first box in here, we take the input, and this one is for the output. So there are 4 different methods that we presented at the moment. So if we put the sentence like ខ្ញុំស្រឡាញ់ ប្រទេសកម្ពុជា and the ICU work well, and also you can select on different method, and the output will based on the method that you selected. And so we test with another word is machine បោកខោអាវ So as you can see that this word for the on-and, it separate the word, but it for ICU, machine បោកខោអាវ is only one word. Sim spell also only one word. For the conditional random field, it separate into 3 words. Machine is a word, បោក is a word, and ខោអាវ is another word. So for this one, we take the text from the article Cambodia Daily, and we take a text from here, and we input into yes, and this one is, as we can see that there is ICU method. This output for ICU method, and sim spell, conditional random field, so I think that's all for the demo part.
So thank you for your presentation. So now you have 3 minutes to answer the question. Thank you.
So for the question,
Okay, so let's do the Q&A. So teacher Nguyen Chai, he asked how to deal with the data saw the tax máy or data something like tax máy the when is basically it depends on the method we use. So as like I showcased with the machine bulk I want, some method will be able to separate it, and some method will not, and might put it to a single. But as our instructor Rina said, using ORM, it can take into context of the previous spot, since the ORM keep track of the internal memory and state of the previous info, so it might be able to detect the context of the word. And for Mr. Hua, so based on our implementation, for like the speed, I think I'm not sure which one is the fastest, but the sim spell one works a bit slow because you need to load the dictionary each time, and for both the conditional random field and the recurrent neural network, we have to create a model and train it first in order and load the model later use. But like for the ICU is pretty fast because it's already have the dictionary loaded, so we don't have to train our model. But for
for just for like normal use case, they are both like equally fast and work instantly.
Okay, so I think we have reached an end with the question and answer part. Yeah, so thank you very much, Bong, for your presentation. Now we will invite another team to present on the face recognition project that they are doing. So please welcome Yemeng and Chikan. Yes.
Hello everyone. My name is Yemeng, and I am here with my team, Chikang. We work on face recognition project, and our supervisor is Mr. Rina Boy. Next. This is the content we are going to discuss today. We are a senior student at Paragon University, and we build this project in educational purpose to know how to utilize the deep learning technology. And this project is also guided in the course. Next. Our problem statement. Next. We for company to track their employee, it is hard because tracking employee attendance is inconvenient. For me as an employee, sometimes I forget to scan my fingerprint when I leave the office, or I forget to scan my fingerprint when I come to the office, so it's inconvenient. Second, it costly. The machine and management system is expensive. The component that used to scan. The third is time consuming. You will need to stand and wait in line to scan your fingerprint if you work in a big company. Next. So our solution is to utilize the deep learning technology in order to use in attendance system in company. Next. Our objective. Next. Our objective is to detect the face. Then our second objective is to recognize the face. It's about methodology. I'll give the floor to Mr. Chikang.
Okay, so my name is Chikang, and I will take over from here. So for the methodology, the library that we use is OpenCV. The OpenCV is used to detect the face, and the face. The face library is used to recognize the face, and the tkinter is just a Python library to create a window form. So for the model that we use to detect to recognize the face is called VGG face, and this is the neural network architecture. So on the left here, you can see we input an image 224 by 224, and we run a convolutional convolution layer 64 and 2 times, and we perform the max pooling to convert it to a different form, and then we basically what we do is just try and reduce the data in the image so that the computer can have an easier time to read the image. So at the end, we can see the final product would be 2,622 data for the computer to use. Okay, so next is how we measure the face. So this softmax here, the output here, we use it to perform a cosine similarity to check if the face mesh together, and if the output is more than a certain threshold, then we say that the face match. But if it is lesser than some threshold, we will say that the face does not match. Okay, so I will show you the demo. Okay, so this is our form. It's just very simple. It have this face recognition button and the register face button. So I will show you. So this is where we store the image of the employee or student. So for now, we only have image picture, and the this one, the other is just a random picture of Asian online that I found to detect if the program have any flaw. So for now, it doesn't have any picture of mine, so I will try to recognize my face. Okay, so here the VGG face model is built, and then it starts to read the images in the database. Okay, so this is the face recognition program, and for now, it does not recognize my face. It can only detect my face, so it doesn't have any output yet. And what you see just now is just some small error. Okay, so now I will register my face. So it create a directory here with my name. And then for every 3 seconds, it will capture my face. So I will try to give it different angle. Okay, so I think eight image is enough. So now I will go back to the face recognition to see if it can detect my face. So now it will load the data again, but this time with with my face in it. Okay, and as you can see, it detect my face and it output the name here. Okay, now I will quit the program and show where I store my face. So here is the face that I just registered just now. And yeah, that's all for my demo. So next is future work. So for now, it can detect and recognize the correct face most of the time. And so for future work, we plan to work on the employee attendance system, like Elaine said just now. And we also see it can be an application for student attendance also. So that's all for my project. Thank you. And if you have any questions, feel free to ask.
Yes, thank you, Bong, for your presentation and also for question and answer. Can you chat, yeah, and reply to the chat? Because since we're running out of time, I think we're gonna move on to the next thing.
Okay, so
Yes. Yeah, Bong.
we can detect with glass, but if we wear mask, it cannot detect.
Yes, Bong. Yes. Thank you for your answer. Yes. So as a reminder for the next team and for participants inside the call, if you guys have any question, you can put it in the in call messages in Google Meet, and after the presentation, the team can reply in your Google Meet, and we can move on to the next team since we're running out of time. So right now, I'm gonna move on to the next team, which is Find Me, presented by Monbiset, Lee Monbiset, Bonarat Hieng, and Siep Mei. Yes. So please welcome.
So, hello everyone, and thanks for joining with us today. Today, I would like to represent my team to present you to a project named Find Me, and thanks for our professor as well, as he has guided us through this project. And once again, welcome to Find Me. For today's agenda, we will walk you through with some introduction, modeling, demo, and finally conclusion. So first thing first, what is Find Me? Find Me is just a basic search engine which rank document with an in-house algorithm combining term frequency, inverted document frequency, probabilistic model, and quality of the web page take into account. And we have three members, which are Monbiset Lee, Bonarat Hieng, and Siep Mei Chien. So this project is built upon our knowledge that we have gained through the course. Therefore, today we would like to share it to you as well as what we have learned from this project. So why do we want to build this project? Because we want to learn how search engine work under the hood, as well as to apply our knowledge that we have been learned in the course. And finally, to challenge ourselves with something we haven't done before. So basically, we just want to build a search engine which user can search with keyword and compute the relevancy of the document, then return it back to the user. For now, we just want to target only Stack Overflow because of our hardware constraint. So even now, there are 99% left of the Stack Overflow web pages that we have been crawled. Now let's move to modeling stuff. Basically, we use three tools. For pre-processing and API, we use Python Flask. And for data store, we use Neo4j, which is a graph database. And we also build the user interface with Flutter. In Find Me, we have two models. The first one is document model, which has the URL, title, and description, and another one is keyword that only has the keyword property. And also we can see that in document we can have many keywords in it, alongside with the frequency of how many times that keyword appear in the document. And one more important thing to notice is that the document itself can self-reference to itself. This is for quality of the website computation purpose that we will explain later. Now let me show some visual example of how our model look like rather than just a diagram. So the above picture is the document model, and the line cut through here is the indicate the relation between each document. And the second picture is for the green node is a document model, and the pink node is a keyword model. And we can see the keyword can appear in the document by the relationship between the nodes. So in the system, we have three components. Crawling, which is just downloading the information from the page. And the second component is indexing, which is a pre-processing to have the ranking document faster. And finally, we have ranking, which is a real-time processing to rank document, and then we return it back to user. Now let's go some in-depth process. For crawling, we have two processes. First, we get the whitelisted domain, and then we go through each domain and pass the sitemap if it's available, and get the URL from the sitemap and store in the document model alongside with the domain. And the second step, we crawl the metadata as well as the URL in that each document, and then we filter out some URL that are not allowed in robot.txt. After that, we store the data in the document model and as well as a new document model that we have found. For indexing process, we just do the tokenization on title and description, and then we stamp that tokenization. And finally, we create the keyword with relation to that document. And the last component, which is ranking. First, we need to wait for the user input, and then once again, we do the tokenization and stamp the query. After that, we calculate the score with our in-house algorithm. In this process, there are a lot of things happen behind the scene. Like first, we compute TF-IDS, then we pipe it into sigmoid function. For sigmoid function, it's just an activation function. We plug the input and produce the output ranging from 0 to 1. Doing this helps us normalize the data and allow us to weigh it with another score like probabilistic and number reference as well. And next, we compute the probability of the relevancy of the document, and then we pipe it into sigmoid function as well. And then we count the number of reference that document have been referenced by another document. But this time, instead of pipe it into a sigmoid function, we pipe it into min-max activation function, because number of reference can go really high, which is not efficient to compute with sigmoid function, which use exponential function. For min-max function, it kind of do the same thing, but with different input and formula. And finally, we can combine it together, weighted 0.5 for TF-IDS score and both 0.25 for probability score and number reference. And the final score will be in range of 0 to 1. Now let's put it a simple word for the whole component and process. First, we fetch the web page, and then we pass the title and description. After that, we breaking it into chunk of word, like word by word, and reduce it to the best or root form, which is not really an English word, but it helps us. And then we're looking for more link in that web page. After that, when we got the user query, we do the tokenization and stemming, and then we rank it with our bespoke algorithm, which to explain in a simple word, just punish words that appear in many documents and given a chance to not so relevant document to be relevant, and as well as given more advantages to the quality document by the number of references. Now let's go to our demo part. But first, I would like to show some statistics of our data store. Basically, we have 5,000 plus of documents that we have been crawled, along with 7,000 plus keywords. And if we compare to Stack Overflow, which has approximately 21 million plus document, we only completed the crawling part in 0.025%, which is really small. And if we compare to the whole internet, it dropped more, like it really small data set. So yes. And here's some comparison between other search engine. For the search query, we use how can I use Node.js, and the top result in our search engine is how to decide when to use Node.js. If you can notice, this is also appear in Google, DuckDuckGo, and Microsoft Bing as well. However, this comparison does not mean like we want to compete with other search engine, but to test that if that document is in our database, chances are we may be able to return the relevant document to you. Because as of now, we cannot crawl the whole internet or even the whole Stack Overflow with our tiny machine. It can take forever to do that. And here is some more example on how to use singleton pattern query. And here is another example, which is I recall line use CSS. And as we can see, the return search result is performed quite well compared to what we want to search for. So now let us share some learning points in this project. First, most of the time, users are not reliable source of truth. Sometimes they don't even know what to look for. That's why probabilistic model kicks in this sentence, in this situation, because it gives the chance of not so relevant document to be relevant to user. And sometimes user can also make mistake in grammar or part of speech, and we solve that problem using stemming. And another point, to make a good search engine, time and resources are needed to produce a good search engine with computational power to make querying consume less time. And finally, search engine algorithm should change after a period of time. And if you can recall, we introduced ranking by number of references, which is easily be abused by user. And as we know, most or maybe all the search engine, they don't publish their exact algorithm on how they rank the document. And this is the reason, and they usually change the algorithm as well. That's all for my presentation, and thank you for joining with us today.
Thank you very much for sharing. Yes, so if you guys have, if the participant have any question, you can put it in the chat and the group will try to answer your question. So yes, since we're running out of time, we will move on to the final group, which works on the COVID-19 chatbot by Chi Kim Sai and Chi Kim Hong. Yes.
Hello everyone. We are from CS382, and our project is about chatbot. And here is our chatbot content. The motivation, we build this chatbot to solve the user problem that they are facing. Which as nowadays we can see people have a problem to contact or chat to Ministry of Health and other people who involved this COVID-19. So I think we build it to for user to ask any question that related to COVID-19 at any time and anywhere, and receive a response quickly after asking a question. And our objective is to make the chatbot that looks convenient for people to ask questions related to COVID-19 without calling to the Ministry of Health and take time and waiting too long. And moreover, we want to make chatbot able to answer questions related to COVID-19 as much as possible, like general question about COVID-19, COVID-19 vaccine, COVID-19 cases, and more, and as well as official. Our model, our project is we use a ChatView tool, and which is a tool that allows people to create and maintain chatbot for various messages. And our data set is from a World Health Organization, which is precise and official, and people will feel more confident and trust our answer. I will show our demo, and we do chatbot COVID-19 chatbot on Messenger. Let's start. Before start asking questions, people have to click get started. So the chatbot will start chatting to us, as you can see here. So let us what is COVID-19? So our chatbot will provide a short definition of COVID-19, and people can ask more like what are the symptoms that people mostly ask about it. So our chatbot will provide the different symptoms, like the common symptom, less symptom, and the serious symptom. And the important question one is also about the vaccine. They can ask any question related to vaccine, like is there vaccine for COVID-19? Actually, we have so many questions here, but we just pick up some important questions to show you. And if they have concern about COVID-19 vaccine, they can ask like what are the benefit of getting vaccinated. And it will provide the answer. And they can ask about side effects, like what are side effects of 19 vaccine. So it will respond the side effect of COVID vaccine, and the last one is about cases, and user can ask like, could you tell me the COVID-19 cases. So it will respond to the user that if you want to know about COVID-19 case in specific country, like in Cambodia, they can click the button see now. So it will link to the official website that provide the official case. Yes, that's all of our presentation. For the question, how do you train your bot to understand the place of user input? Actually, we tested so many times and we generate keyword into our chatbot. Like we generate some important keyword like COVID-19, vaccine, symptoms, cases, like that. This is those are keywords that user always ask. So I think those keywords is very important to put into our chatbot. It's all for our presentation.
Yes. So thank you very much, the chatbot demo team for your presentation. So right now we have come to an end to the first period of IT days. Right now we are going to move to the lunch period, and we will continue from our sessions at 1 p.m. Yes. So thank you very much, everyone, for joining.